Hi friends, today we are going to discuss fluid mechanics chapter 3. I think this session is very useful those who are preparing competitive exams like TRB polytechnic exam, GATE exam and other state government exams. In this session we will discuss important points and some of the problem related to this chapter. Before going to the session, please subscribe our channel and share to your friends. So what is buoyancy force? When the body immersed in a fluid, an upward force is exerted by the fluid on the body. This upward force is equal to weight of the fluid displaced by the body and is called force of buoyancy. The buoyant force is equal to weight of displaced fluid. Next, metacentric height. It is the distance between the metacenter of the floating body and the center of gravity. So this can be calculated the analytical method with the formula metacentric is equal to I by V minus B into G. So that is nothing. I is moment of inertia and V is the volume of submerged body. So next important condition of equilibrium of floating and submerged bodies. So stability of submerged body. The stable equilibrium, when the body is submerged in a fluid, it must be in a stable equilibrium. The buoyancy is above the center of gravity. In unstable equilibrium, the buoyancy below the center of gravity. For neutral equilibrium, B and G are in the same point. So similarly, the stability of floating body. Here, when the body is floating, that means it is in a stable equilibrium, the metacenter is above the center of gravity. It is an unstable equilibrium, the metacenter M below the G. Whether it is in a neutral equilibrium, M and G are in the same point. So when the body is floating, it has to be some oscillation. The for time period for the oscillation we calculated T equal to 2 pi root of k square divided by G into Gm. Here the k is least radius of gyration. So here we discuss some of problem related to this chapter. First, a rectangle pentome is 5 meter long and 3 meter wide and 1.2 meter height. The depth of immersion of the pontoon is 0.8 meter in a sea water. If the center of gravity is 0.6 meter above the bottom of the pontoon. Determine the metacentric height. The density for seawater 1025 kg per meter cube. So here the problem and the representation of the figure as given. So the dimension of the pontoon is given 5 meter by 3 meter by 1.2 meter. The depth of immersion h dash 0.8 meter. So now the figure represents the bottom is A and B and G representing the figure. So now the distance of AG is given 0.6 meter. That means center of gravity. Now AB, that is equal to depth of immersion divided by 2. 0.8 divided by 2, you will get 0.4 meter. Now the metacentric height M is equal to I by V minus B into G. So you know the rectangle section, the moment of inertia I is equal to BD cube by 12. So substitute, you will get 45 by 4. Similarly, volume of the rectangle B into D into H. Here the H must to submit depth of immersion. So 5 into 3 into 0.8, you will get 12 meter cube. Now the BG, AG minus AB. So that is equal to 0.2 meter. Substitute all the value, you will get metacenter height is 0.7375 meter. So next problem, a solid cylinder of diameter 4 meter has an height of 3 meter. Find the metacenter height of the cylinder when it is floating in water with its axis vertical. The specific gravity of the cylinder is 0.6. So in this problem, the depth of immersion is not given. Instead of depth of immersion directly not given, they are given the specific gravity of cylinder. So based on that, we find the depth of immersion. So the depth of immersion is specific gravity of the cylinder multiply with depth of cylinder or height of cylinder. So 0.6 into 3, you will get 1.8 meter. So now same AG equal to 3 by 2, that is the center of gravity, and distance of AB from the bottom 1.8, that is height of immersion, depth of immersion 1.8 divided by 2. Now metacentric height I by V minus BG. Here the moment of inertia I is equal to pi d power 4 divided by 64, and volume is pi d square divided by 4 into h dash. So now BG equal to AG minus AB, you will get 0.6. So substitute all the value, you will get metacentric height minus 0.05 meter. So the negative sign indicate it is nothing, the metacenter below the center of gravity. That means that when a floating body is unstable equilibrium. Next, problem number 3. A rectangle wooden block 2 meter long, 1 meter wide and 1 meter height float in a water. Find the weight of the body and its metacenter height. If the depth of immersion is 0.75 meter, take specific gravity of the wooden block 0.6. State the body stable or not. Here there are 3 questions in this problem. So first question, weight of the body, and second, metacentric height, and third, statement whether the body is stable or not. So same here, the depth of immersion even 0.75 meter. So now distance AG, that means center of gravity, height by 2, 0.5 meter, and distance AB, depth of immersion divided by 2, you will get 0.375. and weight of the body, now we can calculate weight of the body equal to weight of water displaced. So weight of the body equal to 2 meter into 1 meter into 0.75 into unit weight of water 9.81. So W equal to 14.72 kilonewton. Next, metacentric height M equal to I by V minus B into G. Same value, substitute BD cube by 12 and area BD into H dash. So now metacentric height you will get minus 0.014 meter. And the third, they ask statement. The metacentric height M below the center of gravity, that means the negative sign indicate the metacentric M below the center of gravity, the body is unstable. So next problem number 4. When a wooden block 60 cm by 60 cm in cross section float in a water, if the specific gravity of the wooden block is 0.6, find the maximum height of the block for its stable equilibrium. So there are some important cases. So in this case the geometries are similar. So now they are rectangle geometry, stable equilibrium. The condition for stable equilibrium, h into SB plus 1 by 6 into B square divided by h into SB, it is equal to h. So now when the body is immersed in your water, what is the maximum height when the body is in stable in equilibrium? So now here they are given only 2 data, the section details. So 60 centimeter by 60 centimeter and specific gravity of the wooden block is 0.6. So substitute here all the values. So you will get height equal to 50 centimeter. So maximum the size of the block is 50 centimeter. Now next problem number 5. The least radius of gyration of the ship is 8 meter and the metacentric height is 70 centimeter. Calculate the time period of oscillating of the ship. So here the problem, this type of problem, the time period for oscillating time period, you know the formula, 2 pi into root of k square divided by g into gm. So least radius of gyration of the ship k equal to 8 and metacentric height m is equal to, or gm is equal to 70 centimeter, that is nothing, 0.7 meter. Substitute, you will get the time period for oscillating, you will get 19.18 seconds. Thank you friends. I hope this video is very much useful for your competitive exam preparation.